Hello everyone, welcome to the section on random forest algorithm. Random forest is a very flexible and easy to use machine learning algorithm that produces great result most of the time. In this section, we are going to learn how the random forest algorithm works and several other important aspects of random forest algorithm. We will start with sharing a brief overview about random forest, and we will pretty much follow a very similar pattern as we did for the decision tree. Like, we will look into the different components of random forest. Then we will also look into the practical application of random forest, how we can make a random forest performing better depending on the cases with hyperparameter tuning. And we'll be covering a case study for random forest algorithm using the same HR attrition data that we did for the decision tree algorithm. And post that, we will also look into how we can generate information about variable importance or feature importance using random forest algorithm as well, and other evaluation technique. Let me share a quick introduction to random forest. A random forest is a supervised machine learning algorithm based on ensemble learning. It can be used for both regression and classification problems. The general idea behind random forest is to build multiple decision trees and aggregate them to get an accurate results. As you can see, that random forest is a kind of a natural progression from decision tree here when it comes to a machine learning algorithm. Now, a decision tree is typically a deterministic algorithm, which means if the same data is given to it, the same tree will be produced each time. They tend to overfit for sure, because they build the best tree possible with the given data, but may fail to generalize them when given the unseen data. So, to deal with this problem, random forest comes very handy, and random forest tends to be more accurate than a single decision tree because it minimizes overfitting. So some of the salient features are also highlighted in this part, like, as we are going to use more number of trees, we are able to produce better generalization of the results. It creates a randomness inside these trees, and definitely it's a very robust algorithm comes to classification or regression like problems. And it is also quite effective in terms of capturing the variable or feature interactions while building the model. It sometimes really produces great results even when you are dealing with large datasets. Similar to what we saw for decision tree, they're also capable of dealing with missing observations. And sometimes random forests are used to impute missing observation. Now let's deep dive a bit more and learn about how decision tree models are built. As evident from the discussion we have had so far, so random forest is basically a collection of different decision trees. And when building these decision trees, each time a split in a tree is considered. A random sample of, let's say, m predictors or features is chosen from the overall set of predictors. What do we start with as split candidates from the full set of predictors? The split is allowed to use only one of those chosen predictors that we have. Let's say a few predictors is taken at each split. Now, at step 2, it basically repeats step 1 n number of times so that you have n decision trees built from different random combinations of selected features. Step 3 is to store this prediction or this outcome from each of these trees. So you end up having n outcomes from the n decision trees, let's say. And the final step, you basically calculate the votes for each predicted target and take the mode, which is basically the most frequent target available, which we sometimes term as majority vote prediction. In other words, it basically considers the high voted predicted target as the final prediction from the random forest algorithm. Now, one noticeable element of any random forest algorithm is, in building a random forest, at each split in the tree, the algorithm is not even allowed to consider a majority of the available predictors. So it basically introduces randomness, one in terms of number of trees it builds, at the same time the number of predictors it considers for coming up with the best split. Now, random forest algorithm can be used for both classification and regression. Random forest algorithm is quite effective in either of these cases. So in a regression problem, the prediction for the test instances are made by taking the mean of the predictions made by all the trees. And for classification problem, the results from all the trees are captured, and finally the new record is assigned to the category with majority voting or the mode.